So let's go. So question 10.8 says find the matrix product. So what we're doing is -1, 3, 4h being multiplied by k and 5. So what we're doing is row 1, which is row 1, -1 and 3 by column 1, which is k5, and then row 2, which is 4 and h by the same column 1, which is k and 5. So what we know is that this is a 2 by 2 matrix and a 1 by 2. So therefore, in the end, our result will be a 2 by 1 matrix. So therefore, what we have is -1. So we have a -1 being multiplied by k, and then 3 being multiplied by 5. So it is -1 multiplied by k plus 3 multiplied by 5. Then we have 4 being multiplied by k, and then h being multiplied by 5. So it is 4 multiplied by k plus h multiplied by 5. And then what we have is -1 multiplied by k will leave us with a -k, and 3 multiplied by 5 will leave us with 15. So for the top row, we have -k plus 15. Then we have 4 multiplied by k, which gives us 4k, and h multiplied by 5, which gave us 5h. So we have 4k plus 5h for the second row. And that would have been our final answer. So therefore, the matrix product for this is -k plus 15, 4k plus 5h. Part B now says, hence, find the values of h and k that satisfies the matrix equation, which is below, which is -1, 3, 4h multiplied by k5 is equal to 0, 0. So since we have that, we write that back. So therefore, what we know is that from this part, which is the -1, 3, 4h, we multiply by k5, which is here, we worked that out previously in the other question, and what we know is that that would have worked out to -k plus 15 and 4k plus 5h. So that is what we're equating to 0. So with that now being equating to 0, we can break it apart to solve for the different unknown variables. So first, we're going to start by equating the corresponding rows and solve for k. So what we have is -k plus 15 is equal to 0, and we took that out to -k plus 15 is equal to 0, and therefore the k is negative here. We move it across the equal sign and it becomes a positive k. So what we have is k is equal to 15. So we're basically adding k to both sides of the equation, and we got k is equal to 15. The next part now is 4k plus 5h is equal to 0. So 4k plus 5h is equal to 0. So we know we just solved the value for k, which is 15. So we can substitute that into this second part of the equation. So what we now have is 4 multiplied by 15 plus 5h is equal to 0. When you put 4 multiplied by 15 in your calculator, you will get 60. So therefore, it is now 60 plus 5h is equal to 0. We're now going to move the 60 from the left-hand side to the right-hand side by subtracting 60 from both sides of the equation. The same as saying we're moving it from the left-hand side, so when it goes across the equal sign, the operation changes and it is now a -60. So what we'll have is 5h is equal to negative 60. And now solving for h, it will be h is equal to negative 60 divided by 5, which works out to be a negative 12. So therefore, the values of h and k that satisfies the matrix equation, which is equal to 0, 0, would be where k is equal to 15 and h is equal to negative 12. Part 2 now says, using a matrix method, solve the simultaneous equation. So if we're using the matrix method, in rewriting this, we're having our numbers in 1, or unknown variables, and then the 5 and 13. So it will be 2, 3, 5, negative 5, 1, and xy in the other bracket is equal to 5, 13. So now looking at some general aspect of solving simultaneous equation using the matrix method, what we know is that we're using A being the representative for this is usually being multiplied by xy is equal to, let's say, probably c, which in this case our c is 5, 13. So that is what is generally used. So what we know is that we find the inverse of A and multiply it by both sides of the equation. So that the inverse of A being multiplied by AXY and the inverse of A being multiplied by what is on the right hand side, if we're calling it C, which in this case is 5 and 13. What we know is that inverse of A multiplied by A usually gives the identity matrix. And when the identity matrix is multiplied by any figure, it doesn't change. When the identity matrix is multiplied by any matrix, it doesn't change. So therefore, the identity matrix being multiplied by x and y will leave us with x and y. So therefore, what we'll have is xy is equal to the inverse of A being multiplied by C, which is 5 and 13. So now that we know that general information, we can now solve the simultaneous equation by first looking at replacing A. So we know what A is, which is 2, 3, negative 5, and 1. So we're now going to find the inverse of A. And to do that, we have to first find the determinant of A. So the determinant of A is, first we are multiplying but the diagonals. So it will be 2 multiplied by 1 to give us 2 minus the other diagonal, which is 3 multiplied by negative 5, which will give us negative 15. So that will be 2 minus negative 15. This minus sign multiplied by this minus sign will give us a positive sign. So it is 2 plus 15, which will give us a positive 17. So to remember, to find the inverse of A, we first need to find the determinant. So that is the first aspect of finding the inverse. So therefore, what we'll do now is represent this determinant. So it will be 1 over the determinant, which is 17, and then we change the main diagonals, the position of the main diagonals. So 1 goes at the top, which is represented here, and 2 goes at the bottom, which is represented here, and then flip the signs on the other diagonal. So a positive 3 becomes a negative 3, and a negative 5 becomes a positive 15. So that is how we find the inverse of a matrix. So first we find the determinant, which we did, which works out to be 17 by multiplying the diagonals and doing a subtraction, and then we flip the sign. The second part is flip the sign on the main, we flip the position on the main diagonal and then flip the sign on the other diagonal, and we have now found the inverse of A. So therefore, xy is equal to the inverse of a multiplied by 513, which is a general part that we look at. So that is usually the general case, which we looked at on the slide before. So therefore, now replacing the inverse of a, which we just found, so it will be xy is equal to 1 over 17, in bracket 1 minus 3, 5, 2, and then 5 and 13. So what we're going to do is to work out this matrix here first. So when we do that, it will be 1 multiplied by 5, so row 1 by column 1, then row 2 by column 1. So it will be 1 multiplied by 5 plus negative 3 multiplied by 13, then 5 multiplied by 5 plus 2 multiplied by 13. So that is it. 1 multiplied by 5, which is this right here, plus negative 3 multiplied by 13, which is this right here. Then we have 5 multiplied by 5, which is this right here. Then 2 multiplied by 13, which is this right here. We can now work out the respective parts. So 5 multiplied by 5 will give us 5 multiplied by 1, sorry, will give us 5, plus negative 3 multiplied by 13 will give us negative 39, and then 5 multiplied by 5 will give us 25, and 2 multiplied by 13 will give us 26. We can then go ahead and further simplify. 5 plus negative 39 will give us a negative 34, and 25 plus 26 will give us 51. We can now go ahead and multiply this matrix by our determinant. So it will be 1 over 17 multiplied by negative 34 and 1 over 17 multiplied by 51. When you do negative 34 divided by 17, what you'll get is a negative 2, and when you do 51 divided by 17, you'll get a positive 3. So therefore, x, solving this simultaneous equation, we got x is equal to negative 2 and y is equal to a positive 3. So part B now says, relative to the origin O, we have 0, 0, the position vectors of A and B is where OA is equal to 9, 0 and OB is equal to 3, 6 respectively. The points D and E are on AB and OA respectively, and such that AD, so AD right here is equal to 1/3 of AB and OE is equal to 1/3 of OA. And the following diagram below illustrates all of this. So it says express the following vectors in the form AB, and part 1 we're asked to find AB. So what we know is that A is equal to 9, 0. So therefore, OA is equal to this matrix, which is also given in the question. And B, the point at B is 3, 6. So therefore, OB is equal to this matrix of 3, 6, which is also given in the question. So therefore, AB, which we're asked to find, is therefore AO plus OB. And because now the OA is flipped to AO, it will now change the sign, and what we'll get is a negative 9, 0 plus 3, 6 from OB. So when we do that, what we'll have is a negative 9 plus 3, and that will give us a negative 6, and the 0 plus 6 will give us 6. So it is a negative 9 plus 3 and a negative 0, which doesn't have any value, plus 0, which will give us 6. So therefore, our answer for AB is negative 6. 6. So therefore, negative 6, 6 is in the form AB, which is required by the question. So for this part of the question, now we're asked to find OD. So O from here, OD going straight across. So what we know is that that will be made up of a combination. So therefore, OD will be equal to OA plus AD. We don't know what the value of AD is as yet, but the question told us that AD is equal to 1/3 of AB. We just found what AB is, so therefore we can now work out what AD is. And therefore AD is equal to 1/3 of AB. We found out just now in part 1 that AB is equal to negative 6, 6. So therefore AD is equal to 1/3 of negative 6, 6. So what you're doing is negative 6 divided by 3 and the positive 6 divided by 3. So what you'll get is AD is equal to a negative 2, 2. So negative 6 divided by 3 will give us the negative 2, and the 6 divided by 3 will give us the 2. So now that we know the values or the matrix value for AD, we can now go back to the original equation because we already know what OA was, which was given in the question. So therefore, OD is equal to OA plus AD. We know what OA is, which is 90. We just worked out AD, which is negative 2, 2. So we can now solve for OD. So it is 9 plus negative 2, which will give us a positive 7, and 0 plus 2, which will give us 2. And therefore, our value for OD is equal to 7, 2. And this is written in the AB form, which is required by the question. Part 3 now asks us to find BE. So it will be from B to E. So BE would be equal to BO plus OE. We already got what BO is, which should have been the flip of OB, so just a negative sign, so it will become negative 3, 6. We don't know what OE is, but the question told us that OE is equal to 1/3 of OA. We already have what OA is. So it's just to plug this into our formula and get the corresponding value. So OE is equal to 1/3 of OA. We know what OA is, which is 90. So therefore it will be 1/3, 9 and 0, which will be 9 divided by 3 and 0 divided by 3. So what we'll have is 9 divided by 3 to give us 3, and 0 divided by 3, which will give us 0, obviously. So therefore, we can now plug this back into our formula of BE is equal to BO plus OE, and therefore that would be a negative 3, negative 6 plus 3, 0. When we do a negative 3 plus 3, we'll get a 0, and when we do negative 6 plus 0, we'll get negative 6. So therefore, our answer for OD is equal to 0, negative 6, and that is our answer in the form of AB, which is required by the question. And that is the end of question 10 and the 2019 Mathematics Paper 2 question. And we'll see you in another video working another paper. Thank you for tuning in.